For those of you that don't know me, I'm Steve Smith. I am the Executive Director of the Technology Council, and it's my pleasure to welcome you here this morning to this beautiful facility and introduce some of the speakers. So first, I'd like to thank our sustaining sponsors. We have 3 companies in the area that have stepped up, and they're all represented here: Cape Light Compact, Cape Cod 5, and Open Cape. And they have generously donated a significant amount of money to keep our programs running, and we thank them very much. So I'd like to just run through our lineup. Dr. Cox is going to open things up. Rick Bsharah is going to talk about his programs and the robotics program here. Andrea Lyons, I think, is on Zoom, and she is going to talk about the IT program. And Louis Bico, Louis, is also going to talk about some of the programs that he is working on here at the college. So we have a really interesting program this morning. Thank you all again for coming. Dr. Cox, take it away.
Thank you. So, all right, be honest. When you had to find the building this morning, how many people had an issue getting here? Okay, well, we're a work in progress. We'll have it all ironed out by the next time you're here. I also want to mention that we have a whole handful of people on standby for the tour. I'm told I'm not the best tour guide. We end up spending too much time at the toilet of the future. I'm very driven by the people that we're leading around here, so we want to make sure everybody's happy. So good morning. As we get started here today, and the theme being preparing for the next generation. Obviously, we're very psyched that for the first time in probably 15 years since we've been on the initial design phase for what you see as the Science and Engineering Center, it's finally up, it's operational, it's a centerpiece for the institution. And it's really, it's not only what goes on in that building in terms of the STEM fields, the science and technology, but when you look at the college more broad-based, you see our information technology, our cybersecurity, you see our work in aviation, you see our expansion now into avionics, you see our takeover of the funeral service program from Mount Ida as that continues to grow. So we continue to monitor the market, we look at where the needs are for our students, and we look to develop programs that will meet their needs and meet the employer's needs across our region. One of the key aspects here that really I think was foundational in the work that we did with the design for the Science and Engineering Center is what we call the robotics evolution. And if you have the time, you go into the building, you'll see where we are today. But if you go back in history and you think about where we came from, and Rick knows this really well, initially housed in what was the former massage therapy center in the gym building, and basically a room with no outside light. Today, completely different. It's a welcoming point when you come into the new Science and Engineering Center, and it really demonstrates where we are in terms of our approach to the STEM fields moving forward. And obviously, when we think about the Frank Maureen Wilkins Science and Engineering Building, we have to be cognizant of the piece that not only is this something that the college community, the science and engineering faculty, the STEM faculty were very much involved in, but the community really helped drive the effort here. It was a $10 million capital campaign that made this possible. The state funded a portion, but without that $10 million, what you see over there would never have happened. So community interest in seeing this happen, major piece in our success today. Just in reflecting a little bit about some of the things that have gone on in the development around that building, and really the notion of sometimes how long it takes things to gel when we're going from the idea on paper to the actual execution, whether it's a new aviation program or whether it's the toilet of the future. When we go back and we reflect on the history of how we got to where we were, it was an introduction to technology in the field back in 2014 in India that we saw, hey, this technology may have some application on the Cape where we have a wastewater issue. Maybe there are alternatives. Instead of building sewers everywhere, we can work on some technological approaches. So we worked with the Gates Foundation. They had the Reinvent the Toilet initiative in 2012. Their winning technology was put out by Caltech. We were introduced to the folks that developed that. We worked with them. Our faculty was very much involved, along with the DCAM folks, to work on a design that we could actually slip into the building. And even with the pandemic going on, we were fortunate that the modular unit arrived and it's on full display for you to see today. So patience is clearly a virtue. When we think of some of the other operations, not necessarily here on the main campus, aviation at the Plymouth Municipal Airport, we have FAA approval to expand it now to 245 students. We have a major federal grant to expand into avionics. We have basically pulled together a direct partnership with Airbus. We're doing some specific training on the care of their aircraft, and the program continues to grow. Students get great jobs. And go a little further up the road at Bridgewater State, we have our funeral service program, which also continues to grow. And as a matter of fact, we are moving to a new facility in the center of the Bridgewater State campus as we enter a 20-year partnership to keep that lab space up and running to support our students moving forward. And then finally, we have our cyber crime issue that some of you may remember from 2018 when the college had a cyber crime breach, and we lost initially a large sum of money to the tune of a little bit north of $800,000. Over the course of, I guess, the last 4 years, we've continued to work with law enforcement and the bank investigators. We've recovered most of the funds that were stolen. We supported the government's case in the prosecution of one of the ringleaders of the crime. And just last month, that individual was sentenced to more than 10 years in prison. So it was a learning opportunity in many ways for us as we continue to emphasize the need to grow the exposure to cyber security. And then perhaps the biggest news in terms of changes for the future, the governor has rolled out what we call Mass Reconnect. This will be a funding mechanism for students 25 and older that don't have a degree. They come back to college, they fill out their FAFSA form, they see if they're qualified for any federal aid, the Pell Grant, the Mass Grant, and then whatever remains through the Reconnect program, the state will cover in terms of tuition and fees. Basically, we're getting to free community college at this point for the folks that are 25 and older. We're trying to really energize them to return to school and complete those degrees. That will be a game changer for us as we move forward. And we're optimistic that over time, we'll move away from the 25 and push it back down to that is it for me. Any questions?
Do you see in the future growing into anything like astronomy?
I would defer to our team.
We do have an astronomy class.
Yeah, my daughter's going to be doing a little more next year, but do you see that growing?
I'll have to, we'd have to think about that.
Okay. Please.
You not only can see it, you can experience it.
Well, many flushes a day do we have?
Wait, you know, here we go again. That's the future thing.
I speak clean things, so that's why we can't all use it.
You know, when we approached the state to do
There's
part of the
definitely a lot.
future,
Yeah.
there were a lot of hurdles that we had to blow through. And the one that I guess is eventually panned out was it became a pilot project. And the state said you're limited to 44 flushes a day. We said, fine. I'm not quite sure who's keeping count, but we do monitor the tanks and we monitor the flow of the water, so we know when we have issues with capacity. But it's there, and the hope is we understand the technology moving forward. We can perhaps look at new ways to reduce the cost of the technology and increase the application to other venues.
You didn't emphasize, but you really specifically mentioned Foresee's programs that actually reach out and touch other physical facilities like Bridgewater. To those of us who are not that up to date on community colleges in general and yours, it's interesting to hear you talk about having a physical and program presence in geographic areas beyond this campus. What's that about?
Well, we actually, there is a map where the community colleges are plotted out into the theoretical service area. And our service area goes from Newtown to Duxbury out beyond Darien Island. The issue with Bridgewater was really, we jumped into saving the funeral service program when Mount Ida closed. When Mount Ida closed, literally 2 weeks before they closed, they were still accepting students in the programs. We went up, we met with them, and this was April of 2018, and it was a question of how fast can we get this program up and running. And we knew we had capacity issues here on the main campus. We also wanted to try to mimic the setup that it was coming from, which was a linear campus. We have a very strong working relationship with Bridgewater. They had some space available, and we basically said, how quickly can we pull something together? So over 4 months, we built out the teaching and learning lab space and office space for the faculty, and we secured the American Board of Funeral Service Education accreditation to do the teach out for the students that were already in the program, so that they could basically change direction, and for the fall they could restart with us. So I think the speed element was critical in driving a lot of that decision at the time, but it has really flourished, and it's serving a great need in terms of the education services.
You have other potentials that mimic that kind of a setup?
Well, it's funny, when we catch wind of institutions that are sort of on the fritz, we do reach out and we have some dialogue. And I would say if you look back at all the institutions that have closed over the past 50 years, we've cut space with all of them at a certain level. A lot of times it's really location driven. We have programs that are specific to certain record holders. They're looking at something down the street that they can shift to. But every now and then you catch the one off with the funeral service, and we were able to bring the faculty basically.
Certainly one of the best ways to do workforce development is, besides sort of looking at being sure that the classes you're offering are leading to some kind of position, is through apprenticeship programs. Can you talk to us about what you're doing in terms of thinking about apprenticeship programs or companies that you're working with?
Sure. So I'm Don Crampton. I'm the Dean of STEM here at Cod Community College. Apprenticeships can be more difficult. I think definition of an apprenticeship generally means you've got a job right after that job. Those are few and far between. There's a lot of state and federal push to create apprenticeships. That push hasn't necessarily been all that fruitful yet. We do have a lot of interactions with local companies, obviously. I think Bsharah has a lot of good connections. A lot of our students have internships or co-ops. I think Andrea and students have a lot of different, we call them, I think, internships, we probably call them co-ops. We have a brand new blue economy degree, and that is, you must get an internship or a co-op at a company on the Cape. So we are trying to become a bit more internship, a bit more work learn, but as of yet, we don't have that many apprenticeships.
To add to that, which I was going to my spill a little bit, from the IT perspective, we've started to reach back out to organizations, and they're actually starting to take on graduating students or interns, and so we're working on programs for that to get students to get jobs literally after graduation. So when I originally first started the program, we were able to get some students into jobs, and COVID happened, and now we're starting to pick that back up again. So I'll explain some of that when I get up and do my spill.
All right, so my name's Bsharah. I didn't go to the first slide. I'm here to kind of give you just a little bit of an overview of our engineering, sciences, and applied technology department, which includes sort of our core engineering, as well as our cybersecurity, as well as the rest of our IT, as well as our aviation maintenance program. So I'm going to give kind of an overview of what we do within that department, show you some photos that basically that hopefully will entice you to want to take the tours that we're going to have afterwards. But please ask questions. If anything I'm saying, don't wait till the end. Ask right away. So I can talk forever, or I can go really fast. So I know we have Andrea, who's a great speaker, and Lewis will also be speaking. Also a great speaker, I should say, as well. Be on. And so I think I'll just start by saying we're the department that makes and breaks things. You think about it, whether it's code that you're writing, you try to break it, see if what's going wrong. If it's a product that my students might be doing on the engineering side, that's part of what we do. We teach the design process, and the design process involves not just making it perfect. It never works perfectly the first time. We all know that. So it's all about getting into that mindset of how do you solve problems, how do you create new things, how do you test them, how you evaluate them, I should say test and evaluate, and then how you fix them and make them better and improve them. And that's our process, that's what we're doing. And that's how we kind of recruit people. We say if you have that mindset where you like solving problems, where you like inventing, where you like creating, we're the department for you. Okay? And just recently, we've opened a new building, where along with this building that you're in right now are the two newest buildings on campus. So most of our IT stuff is in this building, most of our engineering is in the other building, but then we're sharing a lot of classroom spaces because of the different shared technologies that we're using. As far as degrees and certificates that we offer, it's quite a handful that we've got. We've got Associate of Science degrees, we have Associate of Arts degrees. You can read the different subcategories on those. And then we have a host of certificates that someone can earn within 12 to 24 months. And the certificates many times become stepping stones to then go on and get the associate's degree. And then the associate's degree becomes a stepping stone to getting the bachelor's degree or a master's or even a doctorate. Okay? And we, on that vein of going on after 4 Cs, we have articulation agreements within the engineering program with all the UMass schools, with WPI, with Northeastern, and with other schools. And you can go to our the college website, and if you search on the word transfer, it'll actually bring up the entire set of transfer, or what we call articulation agreements, with all the different schools in the state that we're articulating with. And then for schools that are out of state, if someone wants to go, to school in California, there's mass transfer pathways that we can talk about. And most of the courses that we're teaching carry over into 4-year programs very nicely. In other words, the faculty have bent over backwards to make sure that what we're teaching is compatible with all the institutions that might be offering higher level degrees. Okay? Because what I'm trying to do with that little sales pitch back there was just say, we're not, grade 13. We are really a college. We do teach students at the same level of rigor that every 4-year institution requires of their students. And in many cases, I would say, and of course I'm biased, that we're better than they are, because we offer smaller class sizes. We offer more challenging problem sets because we can spend more face time with those students. Okay? Now, the great thing is that we have a brand new science and engineering center. So combined with the building that you're in right now, the Lorusso Tech building, we have some great state-of-the-art labs. We have some great state-of-the-art teaching facilities. Our labs you can see listed on here. We have a robotics lab, we have a CAD additive manufacturing lab, we have a material science lab, and we have a makerspace. And all of those things are available to the students taking classes. The makerspace is even available to the community. So now I'll just show you some examples and talk you through a little bit about what's in those labs. So here you see our robotics, pictures of our robotics lab. We have 2 collaborative robots. Those are those red ones that you see down in the lower right-hand corner. They're Rethink Robotics collaborative robots. A collaborative robot is designed to work next to people without any need for safety cages. The yellow one that you see in the upper left-hand corner is a FANUC industrial robot. That requires a safety cage. That's what you see when you watch maybe a video of an automotive assembly line. Those big things moving, heavy pieces of equipment very quickly. You get in the way of one of those, you're going to get hurt. So you need all sorts of safety stuff. So we teach both kinds of robotics on the sense of manufacturing shop floor. And then we also have mobile robots like the Mir 100 that you see with the cover off it. That's the one that's, use the mouse to just point at it. I won't use the mouse, it doesn't go very well. But the one that's in the middle on the lower portion, that's a Mir. That's like the one if you go to Stop and Shop, the one that goes up and down the aisles and annoys you. Okay, those are autonomous robots. They're going, they sense whether you're there, they move, they either stop or drive around you. That's what we're teaching our students as well. They're not really, the money isn't for a mobile robot to have it in a grocery store. It's in a warehouse setting. If you think of warehouses, big warehouses, people used to have to run up and down or ride bicycles to go from one aisle to another to take packages down. Mobile robots can do the same thing much more efficiently. They don't get tired. They don't accidentally read things wrong, stuff like that. So we're teaching mobile robots. The reason the cover's off is because part of what we do is we teach all the technology around the sensors. There's 36 different sensors built into the mobile robot. It's not an educational robot. It is truly one that you could go find inside an Amazon warehouse or Google site somewhere. Okay. So we are giving our students that in education about how to not only maintain the robots, but how to also introduce those into a work environment. Because that's the number one thing. People either, the first day of a robotics class, the student either asks, is there going to be a robot apocalypse? That's question 1. And then the second one, is this going to put me out of work, or is this going to take my job away? And we have to address those issues. And yes, some jobs are lost because of robotics. And then one of the big pushes right now is you're going to start seeing more and more robots in fast food businesses. You know, the McDonald's are now using collaborative robots to be the line cooks. One, because they can't find people that want to do that work, or can't find enough. There's definitely some that want to do it, but not enough. And then secondly, it's just more cost effective. So I don't know what the real number is, but I'll make up a number. Let's say there were 25,000 line cooks in the United States last year. There might be only 15,000 or 5,000 in 2 or 3 years, because a lot of the places are moving into a realm of automation. So one of the things we teach is that you need to constantly educate yourself and keep ahead of the curve if you want to stay employed. Because we're not going to not have robotics. I mean, in a sense, if I get again on my soapbox that I really haven't gotten off of yet, you know, the US is falling behind the rest of the world in automation technology. We used to be the leader. Now we're, depending on whose chart you look at, either 4th or 7th in the world. And we're constantly falling farther behind. So where do you buy the greatest products? They're not made in America anymore, in many cases. So we're trying to change that. We're trying to change the mindset of our students so they understand what automation and technology enables them to do. And we're also teaching them how to work and interface with other people, other businesses, and how to best bring in new technology. And so all of our courses sort of have a problem-solving paradigm that they follow, where students just aren't taught theory, but they're taught implementation as well. Okay? So these are just, that's a picture of our robotics lab. One of the things we try to do is keep everything fun, so every semester there's some kind of capstone-ish, mini capstone kind of project. Last fall, the project was they had to program all those robots that you saw on the previous slide to support students other students during finals week, to give them a break, something to relieve the stress. So that we had these games of tic-tac-toe where you could challenge the robot to play tic-tac-toe and see who would win, and then, you know, another robot would give a prize. So in the upper corner, you see one of the mobile robot going in and out of an elevator. Okay, so if you go from one floor of the building to another floor of a building, it sounds like you say, what? Who cares about that? Well, that's actually pretty complicated to do with a robot on an autonomous level. Because as you know, with elevators, when the door opens, there's all sorts of sensors shooting beams back and forth so that, in theory, the door won't slam closed on you. That's a real problem for a robot, or for that matter, something like a self-driving car. If all of a sudden it's inundated with a whole bunch of sensor signals that it doesn't understand. So that challenge right there of just getting a little robot to drive in and out with a poster on it advertising tic-tac-toe took about a week of heavy-duty work by the team to overcome that. And that's the type of stuff that we're teaching at this time. Down below you just see where one of the collaborative robots is actually the device playing the tic-tac-toe with, you know, against a student. So the whole idea is that in this case, each of these robotic arms have cameras on them. So it's using the camera to recognize the shape and in this case, not the shape actually of the pieces. You'll notice all the pieces are round. The only thing the camera could differentiate was the lettering that was on the device. We had an earlier stage where we did it where the X's were square blocks and the O's were the circular ones. But then we decided to make it a little more challenging so they couldn't use sort of the lower level fidelity of the camera, and they had to go in and go even deeper. And then think about the logic that tic-tac-toe entails. You know, it sounds, again, it's like a kid's game. But why do we have kids do it? It's because there's some logic to think about. 2 in a row, I got a block, or I can win, you know, all of that. Our students are learning how to program the robot. So now we're into that IT side of the equation. Writing the code to enable the robot to win some of the time. Here's some other pictures of things. This is another challenge that we had students do a couple of years ago on the lower corner. Same idea though, robots doing things. Okay? And we use, I forgot to mention, I'll just go back. One of the things we start off with are the VEX robots. I don't know if people are familiar. If you have kids in high school, the VEX robots are very popular. We use those as a starting point because some students already know a little bit about robots, so it was a nice way to recruit into the class. And then what we do is we don't allow them to build a new robot with all sorts of weird shapes on it, which is what most students want to do. We say, no, you have to take this existing shape, this clawbot we call it, and you have to get into programming it and using all the sensors. And there's quite a sophisticated set of sensors, from a gyroscope to a GPS sensor to 2 different cameras and an ultrasonic sensor. They're on this little device that they don't get to move around, but they have to program it to navigate a maze. And then from that, we jump them up to the bigger robots. So we're starting small, crawling, walking, and then finally we're running with these various projects we have to do. In our CAD additive manufacturing labs, one of them is in this building, down on the ground floor, room GO2. That's this picture that you're seeing here. Because the room is used for other classes as well, we keep all of our 3D printers in these cages, but you know, they're easy, nice wide doors that open up, and then they're all set up to run. So the students are learning how to use tools like SolidWorks, Inventor, other CAD programs, how to take those designs and then prototype those designs out using various kinds of 3D printers that we've got. We've got approximately 15 FDM printers scattered throughout the campus, 7 in this building, another 10 probably in the new building, and then some scattered elsewhere. Yes, sir.
Does that translate into a CNC machine?
Yes, yes. The same G code that you would use to drive a CNC machine is what is driving our machine. So part of what we teach is how to go from a solid model, or for that matter, how to go from a drawing that somebody might have from a previous design to a solid model representation, to then turn that into G code, and then how to take the G code and optimize that for the particular machine that they're going to be driving. Because every one of these, there's very little standardization in the 3D printing space today. And so on that end, it's a great learning opportunity. The orange printers that you see here, these are ones from a company in Europe, Prusa Labs. And then we have some Form Labs SLA printer here, which is a photopolymerization one. We have, this one is a new MakerBot Stratasys machine that has a heated chamber, so we can do some super high temperature materials, fireproof types of materials. And then this is actually our newest little toy that we've got. This is a food-based 3D printer. What this one does is works with our culinary side of the college, where we can actually take chocolate or marzipan and create 3-dimensional objects that a student designs here. So if you think of the bakery where you might go in and they have maybe a cupcake with, it says happy birthday on the top. Now you could create a design that's the logo of 4Cs, which is actually what you're seeing if I zoomed in on the bottom of this little build pad here. And these are marzipan, and that's pink, white chocolate. It's white chocolate with somebody put some pink food coloring. So it's just it's more of a toy. I call it a toy because it's not going to be used really in an industrial setting unless it's an industrial kitchen. So for catering, these are very popular because, again, think of all the unique things you could make wedding anniversary, et cetera, whatever. But from an engineering point of view, we're not going to be doing structural testing on chocolate candy bars unless it's just a day to, do an open house type of a thing. But it's there, it's fun, it's useful. Students have access to it. It drives them in, gets them hooked, and then they can start working with the real machines. Okay. In our material science lab, this is where we do, it keeps jumping on me. This is the lower picture in the right-hand side is our universal test machine. Makes and breaks things. This is the breaking side of things. We can take stuff up to like an aluminum rod, 1 inch in diameter, and pull it apart or squish it. We can take concrete samples and compress those and see how they behave. And then take another sample of that same size of concrete, see how it behaves in torsion, in tension. So we're teaching the material science lab work is done using this equipment. We also have things in there, that we didn't have a good place to put it, so we put our laser cutter that is in that same lab, but it's right next to our makerspace. So material science, it's all about seeing the strength and analyzing what's going on internally within materials. And so we're teaching that, we're giving students that hands-on experience. Our makerspace is this is open to the public. There's everything from a whole bunch of Acrylity 3D printers to some older MakerBot and some Maker Gear 3D printers that we've got. We've got a paint booth in there. We have a small desktop CNC machine. Okay. A Roland desktop one. Works nice. It even has a rotary attachment that we can put onto it. So we can do a little bit of interesting stuff. If we have larger milling types of activities that we need to do, we work with our local high schools that have bigger machines, or our tech schools. Chose to go down more the additive, smaller machine route rather than the larger machines, just because of budgetary reasons. If you buy one big expensive machine, you can only have a small number of students use that each time. Whereas if we have a whole bunch of little ones, you can get a whole group of 20 students or more engaged. So our makerspace is there, it's open to the public. We work with the public community, we work with local businesses, in other words, on sometimes prototyping parts for them. It becomes great learning opportunities for our students. At this point, I'm at my end, and I want to invite, I don't know why it keeps jumping on me there, but April 28th is our advisory board meeting. Okay? Anybody is welcome to attend our industry advisory board meeting. It is at noon, and I believe the 28th is a Friday. We'll have pizza. No, tacos. Louis wanted tacos. We're having tacos this time. We're having tacos. So please, if you have any interest in helping us become even a better college, the industry advisory board is the way to do it. Okay? Sure.
Question, has there been any discussion in the engineering program of offering ocean engineering classes, potentially partnering with a 4-year?
We have oceanography, we have environmental science classes that we already offer. Those are on our science side. Ocean engineering as a degree is typically a higher level degree. So we would encourage a student that's interested in that field to either do civil or mechanical. And then in their transfer pathway, the credits that they take through us will work fine at the different ocean engineering programs.
I'm wondering if a program like that could be sort of a feeder for one of the 4-year schools like URI, which has widely recognized ocean.
It definitely can be. Our dilemma is that we are the tail of the dog, and we do what we're told with respect to the 4 years in our articulation agreements. So it's even though we have lots of vision of what we would love to do, in many cases we can't just do that and then avoid the issues of what happens to that student when they leave here after 2 years. Because if the employer isn't going to hire them if they don't have the bachelor's degree, we've kind of have to be very careful that I don't want to say we have to be very careful that we don't waste the students' time and money on taking a course that won't transfer. So that's why we have to have articulation agreements with the majority of the schools that the students are going to go to, and we have to make sure that we are teaching to the letter of what those schools want, or they will come back and say, sorry, that student has to retake that class. Because colleges are in the business not to help students really, they're in the business to make money, if you really get down to it. So we are constantly fighting a battle.
Really?
Yeah. I'm sorry, but from my perspective,
Go back to the drawing board.
yeah, I know. I knew that was just to wake you up, that's all. Everybody
You
move.
hit a nerve.
But the whole issue, I know you want me to
I
get
just,
off the stage.
I just want to, I don't want to suppress questioning and whatnot, but we have 2 more speakers we want to get to. So maybe if we can just hold the questions to afterwards, we can do some, post-meeting networking. Everybody will be around and there will be a tour of the new facility. So we want to get everybody, thank you very much.
No problem.
That was really great. Andrea next?
Am I allowed to, can I share my screen?
Absolutely. And Allison, you can do
So
that.
I want to start before I share the screen by explaining that I see this as twofold for the IT programs here. Professor Becko and I, we both want to talk very briefly about what our 3 programs of technology are for Cape Cod Community College, but I also want to reach out and let you know that there are students that are in the meeting today, and this is a first, and we're really excited and thankful that you invited and included students, because we don't see our job as just teaching classes. We see our job as preparing students to get out in the world and either do one of 2 things: continue on to a 4-year college or get jobs. And if we just taught and left them at the door after they finish their classes, we really aren't helping our students. So I would love for us to be able to have time for question and answers with the students to see what they feel like they need and to see what you might feel like you can offer our students. There's 4 things after we talk about the programs that I'd like to discuss, and that's internships and the possibility to step back and think about, could your company possibly support an internship? We have great, strong internships with Cape Air. I found them to be very successful for our help desk students. We are actually in a meeting today. Cape Cod Community College is going to try to start supporting internships for our own help desk with our students. And to be able to prepare them to know what to expect in the real world is just as important as being in the classroom. And so to also add it to their resume makes them look like they're top in the resume pile. The second thing is mentoring. If you couldn't do an internship, or if you could do an internship and mentor a student, to have a student have somebody from industry to help them, whether it's a semester or a whole year, has been invaluable. We have had a STEM starter program where a couple of years ago the focus was to do mentoring, and some of our students got jobs through those mentors. So to have somebody in the field that can answer questions and the student can relate to and get support from is really helpful to the students again. Now, that's helping our students. We need help. We need IT faculty. We need part-time DCE faculty for some of our programs, and just having people to teach some of the technology courses will be extremely helpful. We have 2 full-time IT people, clearly it's Louis and I, and there's 3 full programs with a lot of IT classes in them. So we rely a lot on what we call DCE faculty. And those adjunct faculty members, being experts in working in the field, are so invaluable to our students. So it all goes back to, we make decisions to try to support and help our students be successful. And I think having teachers that are part-time because they work full-time in industry gives them a better education. And that's why, to be honest and not to embarrass Louis, that's what makes him so great, is that he came right from industry. He still works sometimes in industry, and he really knows what he should be teaching his students in order to get jobs. That's a huge difference. So if we could lean on the Tech Council for support and things like that, it's really important. And the last thing is, we came up with a new program this year, completely rewritten. So the whole program, the new help desk program, leaned on the shoulders of our advisory board. Our advisory board tells us what we need to do in school. We don't develop programs in a bubble. No programs in our school are done in a bubble from faculty. If we didn't have outside advisory board members, we wouldn't have strong programs. We wouldn't have programs that would relate to getting students jobs. It all goes back to students again. So if you're not on the advisory board and you would consider being on our advisory board, we have boards that are for every single program at the school. So maybe if you're interested in one of the programs we're talking about today, it is in something else we offer. Or maybe it is and you're in IT and you'd like to try to support us, that'd be great. Okay, so I'm gonna ask that we do have some time for you to talk to the students and the students talk to us, so I'm gonna be really quick on the programs then. Professor Becko or Louis will talk about cyber, but I'll quickly show you the other ones if you don't mind. So I'm going to share my screen and I'm going to jump us into, this is right off our website. I decided not to pull things up, but to show you that our website immediately shows students all the different programs that are available at our school. So I'm going into the first program here, which is the Information Technology program, and say that this program is completely being wiped out. I'm excited to say, as of last month, this program was scrubbed and cleaned and classes were thrown out, and it is completely a help desk program now. We will be, for the first time in the first school, offering 2 Mac OS courses along with our basic Windows courses. We'll have specifically, so none of these courses will be relevant after the semester. Instead, we will be having courses that relate to help desk programs. So I'm going to jump you in and show you that we have a very robust help desk program that's going to be starting in the fall. And again, we can't thank our advisory board because they helped us. But this means that we need adjunct faculty to teach things like the Mac OS course. We left Professor Becko into teaching Windows Server this semester, and he's on a full overload, so we need an adjunct faculty member to once a year teach a Windows Server course. These courses will be offered only once a year, so that's great. We think we already got somebody from Cape Fear who's interested in interviewing for teaching the help desk skills course. So again, anything that can be supported would be great. You can see that these are courses that are relevant to a lot of your help desks, that you would have students that would be available to either do full-time internships, part-time, whatever. I'll second jump you into the networking one, and then I'm going to let Louis talk to you about cyber. So I'm going to explain the cyber program, which is mostly my concentration here. We chose to teach through a Cisco Academy, so all our courses are taught in networking using Cisco. Our school provided us with routers and servers, real routers and servers and switches and everything from Cisco, so that our students learn hands-on how to support Cisco networks. But you don't have to be a Cisco network, because most of the education is the fundamentals of not just learning how to set up or manage a network, but learning how to secure a network. In order to teach this program, it's not an easy program at all. You have to be certified to teach in Cisco. I believe right now in Massachusetts, there's only 3 or 4 faculty members certified to teach Cisco. And Cape Cod has 1, which is me, and that's great. That means on the South Shore, nobody else really has the ability to teach Cisco programs. So our students are getting something that's in demand so much. The fourth level of our networking course, which they take in their final like capstone program, Cisco doesn't even offer. It was written by me, and other schools are trying to use it now. It's literally teaching them routing protocols, languages for routers to talk to each other. They need to get an industry. Those languages are used no matter what type of hardware you have through the network. So our students are able to get out and be able to hit the ground running with anyone's network equipment whatsoever. That's pretty impressive. So I'm going to leave it with that and allow Louis to jump in. And Louis, I'll put up your program, if that's okay.
Yeah.
Okay, let me get yours going then. Your concentration. There you go.
Now you got me nervous.
Why?
Because I anticipated you going at least another 5 minutes or so.
I can talk forever. You guys, any of my students that are in that table will tell you, I don't stop talking. So if you want me to keep talking about the other stuff, I'd be happy to. So you finish. I only want to be able to leave students about 10 minutes so that everyone there can ask you questions and students can then ask everyone their questions.
All right, don't leave me. Hi, my name is Louis Pico. I am the lead instructor for the cybersecurity program. We've been now running the cybersecurity program now for approximately 6.5 years or so. And we've come a long ways. Couple of things. Well, the program is based on taking an individual who's never touched a computer before and to be able to assess it, do value, to do risk assessment, break and fix, and protection, data protection.
Can you stop, Louis, with the capstone semester 1? Just explain to them what we decided to do with semester 1 for everybody.
Sure. So what we have done for this, when we first started the program, students were starting off in different courses of the first semester, and they really had to choose when they first started. What we've done is actually made the first semester to where students can come in and get a taste of IT and then decide, moving into the second semester, which program they would want to go to. We've also kind of moved it to where actually within the first year, if they still aren't sure, they can still transition back to one of the other programs. What we've done or what I've been working on for the students for post-graduation from leaving here, because that's one of my major concerns, actually one of the reasons why I came to teach was because of the lack of talent and the lack of knowledge coming out into the workforce. So what I've done is when the students are preparing to graduate, I've been setting up articulation agreements with some of the institutions, private and public institutions. We just partnered, or we have an articulation agreement with Champlain, and I have currently now 4 students that are actually going there in the fall. I've had students transfer from here to go to UMass Lowell. I've had students go to Northeastern. I've had students go to Boston University, and I've had other students go to other math schools. One of my plans here is to get the school recognized throughout the nation as a center of excellence in cyber, and we're slowly moving up that track. Currently now we are academic partner with eCouncil, so we're able to offer all of their certificates here on campus and actually proctor them and offer them for a discount. I'm also in the progress of working with or getting an academic partnership with CompTIA. If you notice, if you guys are aware, they just partnered with, or let's say, took over Test Out. So we're looking to build that partnership and bring those certifications here to the colleges as well as proctor those exams for a discount. One of the unique things, I'm gonna steal a little bit from Rick, saying that our programs are better programs than the 4-year institutions. I'm actually gonna go a step further and say that the cyber program is one of the top programs within in the region. And I know that because I'm constantly trying to be leveraged by other institutions to come teach there at their institutions, other 2 years and other 4-year institutions as well. The
I'm
master.
going to interject there for a second. So we are, Cod Community College is part of the Mass Cyber Center. So all the schools in Massachusetts meet once a month. I meet with them every month. And we were the first school, 2-year or 4-year, to offer a cyber program. And we were asked, and still are asked constantly, to to support and let them know what we're doing, what we're making changes are. So Professor Becko has really made our school be cutting edge in cybersecurity.
The one thing that the program can hold its hat on, both the networking and the security one, is that our courses, each course within the program, are industry certificate driven. So when a student actually graduates, or I should say completes a course, they are able to go out and take and successfully pass an industry standard certification. In regards to outreach, that was a question in regards to are we working with other institutions and so forth, or are we reaching out to other institutions? Currently, we're not, but I'm just going to say that currently we're not at this moment because we're still building the foundation or strengthening the foundation of the programs locally. But what I am attempting to do is to actually take all of the courses that are currently just face-to-face and move it to a hybrid model. That would allow us to actually extend our reach out beyond the Cape. But there is a problem with marketing, where we're only supposed to market to a certain within the area. But because of the uniqueness of the cyber program and the strength of the program, the word of mouth is getting around what we're actually doing here. Another thing that I'm looking to do is bring some work seminars or programs, bundles, educational program bundles of cyber to the community, free of charge. With us becoming academic partners of eCouncil, we have that ability to do so. I'm just working all the kinks so I can get that orchestrated in house. And that's currently what I have going on at this moment in time.
So
Anything
that's
else?
another thing we should ask is if industry leaders here would ever be interested in coming and being guest speakers to talk to our students. Because we can put things together during off-class hours and invite all the IT students, the engineering students, whatever, to come and listen. And through the ability to do Zooming, many students who are remote actually take classes that wouldn't be considered taking classes, so they would come to guest lecturing. Okay, so I guess at this point, what I would really love is, I listed like 5 things that we would really love to see the Tech Council get involved with, and we have some students here, and I didn't know if any students would be willing to quickly, because I know you guys have to go back to work, but if any of you students would like to say anything.
Listen to the question. Are you looking at a community program for cyber that you're going to do yet?
No, it's literally all drafted up on my laptop. But I'm hoping to get something out by this fall to start introducing it to the community.
Louis, Andrea, what is the best way for folks in the audience and the community to get in touch with you if they're interested in programs, either to speak, internships, that sort of thing? What's the best method of getting in touch? And by the way, the Tech Council is committed to being a partner with the university, with the college, and we are very willing to help broker those relationships. But what is the best way for them to get in touch with you at this point?
Me, I'll be here, so I can pass my information around from that perspective, my Popple card. But catch me on the campus web, in the directory. That'd be the easiest way to get me. I'm still tied in the data center world, so I still live by my phone. So feel free to send me an email and I'll get back in contact with you as much as possible. I will say that I am looking to work with every and anybody, regardless of which discipline, because cyber isn't just technical. It covers all aspects. It doesn't just cover just things IT. So I'm looking to leverage and work with anybody in that regard of trying to get everybody up to a better security stance. We all are in this together.
And I do believe all your email addresses are on the website, right?
Yes.
I mean, so I found that when I was reaching out to the college, you're pretty easy to get in touch with.
I'm very easy to get in touch with, and I do respond.
I put the email addresses right up if you look on the screen.
Yep, we got it. Thanks, Andrea.
Any other questions?
Yeah, Andrea, you mentioned earlier that you're looking for mentors. What's the process by which you assign mentors? And maybe that's one of the connections that we can actually formalize.
Well, I believe the STEM starter program already has a process, but with me sending an email and saying you're ready to mentor, and I'm sticking with them. There's not really, I mean, I will see what it is that you would like to do in regards to the mentorship, and then I will talk to the student and try to match you guys and let you go.
And along with that, I should say that with the new help desk program, we are trying to make a requirement that they take an internship, which I know is different than mentoring, but it means that we will really need to find a lot of help desk interns. And that can be job shadowing with a little hands-on, or it could be fully hands-on. Cape Cod Air has them job shadow for like a week or two, and then they put them right into the help desk with somebody, but being able to independently help the company. We don't want our interns to be first semester or second semester students. We try to make the internships be in their last semester here, so that they have full experience and are able to actually do something for a company.
As one of Andrea's students, John Hughes, come into the Ford Cisco class. So I think I might be able to answer some of what is needed, because what we do is a lot of simulation. The classes themselves sort of take a broad approach and get the vocabulary down, and the next one is a deeper dive, and then the next one is a deeper dive into networking. And so each company here is going to have different tools that they use that it would be impossible to learn them all. So just learning, like, I use Azure and we do it this way and we use this product and, or this type of equipment, just introducing someone to that process. I have a friend in cybersecurity and he had me over for an hour and showed me what he does. And he has different programs that I had never seen before, and his process was different because that's the way his company has developed to, have their cybersecurity. So just introducing students to how your company does that process without, giving up all your secrets, because that's a tough one too. But I think that would be extremely helpful to.
Secrets? What are secrets?
Yeah, we don't have those anymore. But that's about it.
Sorry, that's the cyber humor.
Thank you, John. Very
words.
much. That was great.
2 words in cyber that gets me chuckling: secrets and privacy. Any other
Any
questions?
other students want to say something?
Any questions?
Well, that's really a great presentation. Thank you all very much.